Let's see another classical mechanics problem. So this problem is related to the topic moment of inertia. So here we are going to find moment of inertia of a system containing two masses. So the system consists of two masses. So regarding that, we are going to find moment of inertia. So that is the problem. So here is the problem. So consider a system having two particles of masses m1 and m2 connected by a massless rod of length a. So we need to consider a system and it must have two particles, and masses of those two particles must be m1 and m2, and those two masses are connected by a massless rod of length a. So both of those masses are connected by a massless rod of length a. So in that case they have given some of the options. So that means options regarding, so here they have given where I1, I2 and I3 are principal moments of inertia. So they are the principal moments of inertia for their principal axis. So we need to find out, so according to the options we need to find out what are all the principal moment of inertias. So if you find that, we can choose which option is the correct one. So that is the problem. So answer for this problem is B. So this is the correct option B. So let us see how it is so. So here according to the question, this is the possible diagram. So this is x-axis and this is y-axis and this is z-axis. Actually it has to be like this. So actually all of them are mutually perpendicular. So diagram it is given in this form. So in the question they have given m1 and m2 are two masses separated by a distance a. So if we choose the coordinate axis, so first of all we need to choose a coordinate axis for this problem. So in order to find moment of inertia we need to consider axis. So that the line joining the two masses lies on z-axis. So we have to choose an origin at the center of mass point. So here what we need to do is we need to choose the coordinate axis and in such a way that m1 and m2 are connected by a rod of length a. So here it is given massless rod of length a. So it is massless. Massless rod they are saying because we need to neglect the mass of this rod. Because moment of inertia is nothing but mr square, like that, summation mr square. So we need to neglect that mass. So here these are the two masses. This is m1 and this is m2, and these two masses are connected with this massless rod a. So we need to imagine in such a way that these two masses are connected along the z-axis. That means this is m2 and this is m1 connected by a rod lying along the z-axis. So that is the thing. And origin at the center of mass. So the origin is at the center of mass for these two particles. So this particle might be heavier than this, or else this particle might be heavier than this particle, can't say. So but the center of mass point lies near to the very massive object. So that center of mass point must lie at the origin, they are saying. This is the center of mass point for these two objects. How many, suppose if there is so if there is a mass of 10 kg and here there is a mass of 100 kg. So if these are the two masses, then surely the center of mass point lies very nearer to the heavier mass. So here that is 100 is the heavier mass when compared to the 10 kg mass. Hence, the center of mass point would lie nearer to the very massive mass. So, in the same manner, the center of mass point here also would lie near the very massive mass. So we don't know which is the massive mass, we just need to, we are just given numberings, so that one must lie nearer to the at the origin, and surely the center of mass point not lie at the center, that is a by 2, because both of the masses are not equal. If they are equal, then surely the center of mass point would lie at the a by 2, that is in the middle of that rod. If this is 0, if this is a, like that, if we consider a by 2, I mean exactly in the middle, but it is not the case. So here the center of mass point is origin, that one we need to keep in mind. The coordinate axis or principal axis. So, and what they are saying is the coordinate axis or the principal axis. These coordinate axis, this x-axis, this y-axis, and this z-axis, all of them are principal axis. They are saying. Y means here if we see, if we can take ixy, it would be 0 because x and y are 0 for both the particles. Generally, formula for ixy, here you can see the formula. So actually ixs means along the x-axis summation mi into yi square plus zi square, that is distance from the x-axis. So y coordinate would be at a particular distance from x-axis. In a similar manner, z component z would be, z value would also be at a certain distance from the x-axis. So so if we consider any point on y-axis, so suppose if this is a point on y-axis, surely it will be at a certain distance from the x-axis. In the same manner, if any point on the z-axis, like this m1 mass, it would be at a certain distance from the x-axis. Hence, hence we are having this. So hence we are having ixs is also summation mi into yi square plus zi square, but not xi square, like that, because it would lie exactly at the x-axis only. That point would lie at the x-axis only. So these are at a particular distance from the x-axis, hence we would have y component and z components. So this is the formula for ixx. In the same manner, ixy is also minus m summation mi xi yi mi x into xi yi, because about the xy axis, the axis in the middle of x and y axis, it would be at any point on that. So any point would be at a certain distance from x axis and y axis. So because of that, so about ixy axis passing in between x and y perpendicular axis. So about that axis, any point would be having its own xi coordinates and yi coordinates. In the similar manner, ixz is also minus summation mi into xi zi. That means that particular mass would be at a certain distance from the x-axis and as well as from the z-axis. So these are the formula for moment of inertias. So based on this formula, now if we consider ixy is nothing but here it is. So ixy is nothing but minus summation mi xi into yi, but we have xi yi equals 0 for both the particles, because they are not lying, they are just these particles are lying only along z-axis. So they are not at a they are not having their x coordinate and y coordinates would be 0, because any point lying on the z-axis would have the form 0 comma 0 comma a, that such a form. So that means would have the form 0 comma 0 comma a, any point lying on z-axis. it would have this form 0 0 a. Here if you see x coordinate is 0, y coordinate 0, only z coordinate is there. So hence because of that only x is equals to y equals to 0 for both the particles. We are having, this is the condition. Based on that condition and based on this formula, this mixi as the, in this formula we can see minus summation mi into xi yi. So here xi coordinate is there, yi coordinate is there. As the both these coordinates are 0, then ixy would also be 0. So that is the thing they have mentioned here. In the similar manner, ixz equals to 0 because x component is 0. So whether here if we see mi is there, xi is there, zi is there. So if xi is 0, then it would be 0. If zi is 0, then entire thing would also be 0 because 0 multiplied with anything is 0 again. So hence we would have ixz also equals to 0 and iyz is also equals to 0 because y equals to 0 for both the particles. So that is the thing. And next thing is, next step. Now let m1 lie at z is equals to z1 and m2 at z equals to minus z2 since O is the center of mass. So as we can see, m1 is lying above the xy plane and m2 is lying below the xy plane. That means above the z-axis all would have positive values and below the z-axis all would have negative values. So here it is said that m1 lie at z equals to z1. So this point is nothing but z1 point. Distance from origin to this point is z1. In a similar manner, distance from origin to this point is z2. As it is lying below, it is nothing but minus z2. So m2 is lying at z equals minus z2. And since O is the center of mass, so O is the center of mass point. So based on that, we would have this. Actually, the formula for center of mass point is this. R is equals to m1 r1 plus m2 r2 by m1 plus m2. So this is the formula. So as we already know, center of mass point here is 0, that is origin. So here we would be having 0 in the place of R, and here m1 into z1 minus m plus m2 into minus z2. That is nothing but minus m2 into z2 by m1 plus m2. m1 plus m2 into 0 is nothing but 0. So hence what we would have is this m1 z1 minus m2 z2 equals to 0. That is nothing but m1 z1 is equals to m2 z2 based on this. So this is one of the important formula because here the origin O is the center of mass point. And next is z1 plus z2 is equals to a. Y means this is z1 and this is z2. Actually that is minus z2 because it is lying below, but overall if we consider only the magnitude, so this is z2 and this is z1. So both put together we would have length of the rod because these two masses are connected with the length of the rod a. So hence we are having z1 plus z2 is equals to a. Another form. So from this equation, if we multiply both sides of this equation with m2, so here it is there. So this is like multiplying both sides with m2. So actually it has to be like this. So multiplying both sides of this equation so if we multiply both sides of this equation with m2, what we will get is m2 into z1 plus z2, that is m2 z1 plus m2 z2, a into m2, that is nothing but a m2. So but actually we have already found out m2 z2 is equals to m1 z1. That means in the place of m2 z2 it is replaced with m1 z1. So this is replaced with m1 z1 and we need to take z1 as a common. If we take z1 as a common, we would have m1 plus m2 into z1 is equals to a m2. So this is the thing we are having. So from this if we do rearrangement, That means here A is there. If we send this Z1 to this side and m1 plus m2 to that side, we would have this equation m1 plus m2 by m2 is also a by z1, but actually what we wanted is z1. So z1, if from this if we see z1 is equals to am2, and sending on this m1 plus m2 on this side, we would have am2 by m1 plus m2. So this is nothing but z1, and from z1 we can find z2 from this formula. So if z1 is multiplied with m1 and divided by m2, we would have z2. That means dividing this with m2, we would have m2 would get cancelled, and multiplying with m1. So we would have this. Dividing this z1 by m2 would get cancelled, and multiplying with m1, we would have this m1a into m1 plus m2. This is z2. So now we have found z1 and z2. That means distance from where, from the origin at where m1, mass m1 and m2 are lying. And next thing is I1, that is principal axis, that is nothing but IXS. The formula for this is summation mi into yi square plus zi square. So now if we consider for mass m1 is lying at a distance z1 from origin, but it is not having its own y coordinate. That means m1's coordinate is nothing but 0 0 z1. That means its y coordinate is 0. So hence what we would have is m1 into y1 square is nothing but 0. Then because y1 is 0, m1 into 0 square 0, and m1 into z1 square we would have. So but z1 is, here we have divided m2a by divided by m1 plus m2. Hence m2a divided by m1 plus m2 whole square. That is m1 square into z1 square is this, plus m2 into y2 square is 0, because as y coordinate is absent for the mass m2, because the coordinates of mass m2 is nothing but 0 0 minus z2. So this one m2 y2 square would become 0, and we would have only m2 z2 square, and z2 square is nothing but this. This is z2, formula for z2, m1a by m1 plus m2. So we would have m1a by m1 plus m2 whole square. So now if we see here from this we could take, we would have m1 m2 square, here m2 m1 square. That means in both we can take m1 m2 as the common. So hence we are having here m1 m2. Yeah, if we take m1 m2 as common, that means a square also common, m1 m2 a square if we take common, here what would remain is m2 by m1 plus m2 whole square, here m1 by m1 plus m2 whole square. So if we take it out common, overall we would have again m1 plus m2 by m1 plus m2 whole square. So again in the numerator m1 plus m2, and in the denominator m1 plus m2 would get cancelled. That means so after calculation we would have this. In the numerator we would have m1 plus m2. In the denominator we are having m1 plus m2 whole square. So after cancellation we would have this overall. In the similar manner we would have I2 is equals to m1 m2 a square by m1 plus m2 I2 also, because IYY is equals to summation mi xi square plus zi square. As the x component is 0 for both of them, again we would have m1 z1 square plus m2 z2 square, same manner. And izz is nothing but summation mi into xi square plus yi square, as the x component and yi component are 0 for both the cases. So we would have 0 overall, this would become 0. So hence we would have I1 is equals to m1 m2 a square by m1 plus m2, and I2 is equals to m1 m2 a square by m1 plus m2. That is I1 is equals to I2, but iz is 0. So the option is B. So now only we have derived I1 is also I2 is also m1 m2 a square by m1 plus m2, and I3 is 0. So moment of inertia about the z-axis is 0, because practically, logically also, the no mass is at a particular distance from z-axis. The masses are lying only along the z-axis. Actually, a moment of inertia is nothing but mass into at what distance it is lying from the axis. So as these masses are lying on the z-axis only, they are not lying at any distance. Like if the mass is was lying here, it would be at a particular distance from z-axis. If it is lying here, it would be at a particular distance from z-axis. But they are lying along the z-axis. Hence, moment of inertia about mass distributed about z-axis would be 0. The moment of inertia is nothing but mass distribution. So hence we are having I3 equals to 0. That is nothing but Iz equals to 0. So that is the problem. So thank you.